Welcome friends. Today we will be studying some other aspects of SPSS fundamentals part 3. Let us now look at some of the things that we'll be covering today. First, let us look at how to compute the descriptive statistics of age, performance, emotional intelligence of the employees. So this is we are going to do it. So we go back to the SPSS data file. If you remember, this is the SPSS data file. Now we are going to compute the descriptive statistics for age, performance, and emotional intelligence of the employees. So what we do, we come here and then we go to analyze and go to descriptive statistics and then we go to descriptive. So this is the flow. Analyze descriptive statistics, descriptive. So once we are in descriptives, then we identify those variables whose descriptive statistics we are to compute. One of them is age, so we click on age, we take it in the left side. Then we have performance and emotional intelligence, so we come here. So performance, we have this is the performance, we bring it in the right side, and then we have emotional intelligence, we bring it in the right side. So these are the variables whose descriptive statistics are to be computed. We go to options and we see what are already activated. So mean is already activated, standard deviation is activated, maximum and minimum values are also activated. We may want the variance of the data set as well, so we click on variance, and once we do this, then we click on options. Sorry, we click on continue. So once we click on continue, we come back to the first form, and then we click on OK. As soon as we click on OK, the output window becomes active, and the values are shown. That is maximum value for age is 58, minimum value is 25, average age is 41, standard deviation is 10.02, and variance is 100.44. So this is about age, performance. We can see that 84.8, 3.5. This way we get the mean, medium, standard deviation, variance, maximum, and minimum values. So this is how we calculate the descriptive statistics of the variables you want to work with. We come back to the main database, and then let us look at the next part of the question. It tells later classify it by designation using explore options. Okay, so we have to go to data exploration. So we go to analyze, and then we go to descriptive statistics, and then there is an option, you see, explore. So we click on explore, and then we want here we take the dependent list, like which variables we want to compute. So we go for age, we go for performance index, and we go for emotional intelligence. So these are the variables whose descriptive statistics will be computed, and they are to be classified by designation now. So I click on designation and bringing under factor list. Once you do this, if you want to label cases by, that is identify cases by, you can either use serial number or you can use name, but we are not doing this. And they are telling that what you want, whether you want data or you want descriptive statistics or plots or both. So I keep both, and then let us click on OK and see what happens here. So the output window becomes visible. A lot of computations are done, and now you see you get mean everything, 95% confidence interval of mean, 5% mean, median, variance, standard deviation, maximum, minimum, range, interquartile range, skewness, kurtosis, everything you get about descriptive statistics. But that is classified by officer, executive, and director. So this classification is done for age, same classification is done for performance, and same classification is also done for emotional intelligence. So all this huge data set, this helps us to explore. We may look at it classified by their designation. Then we have steam and leaf plot, we have the box plot for age. So this, you see, one person has become director at a very young age. That person is the outlier. So we have the graphs also for all these different variables, three different variables like emotional intelligence, performance index, and age. So this is how we use the explore option in SPSS to it is being explored by the type of here in this case type is explored by designation, but you can take any categorical value for the purpose of such a type of classification. Like you can get them classified by gender also. You can get them classified by educational level. So this is what we can do. So when you select the dependent list variables, there you should take numerical variables like scale variables, salary before salary after, this type of variables, age, emotional intelligence, etc. But for the purpose of factor list, you have to take those variables which are categorical in nature, like gender, like education level, like designation. Okay, now let us move to the next agenda. Compute outliers in emotional intelligence using standardized values. So we use the standardized values to compute emotional intelligence. So these are the emotional intelligence. Its standardized values will be computed and placed here. How to get it? So standardized means value minus mean divided by variance. So divided by standard deviation. Value minus mean divided by standard deviation. So that is also called as Z score or Z values. So how to do it? We go to analyze, we go to descriptive statistics, and we go to descriptives, and then here emotional intelligence. So other variables you may push back to its original location, so it comes in the left side. Right side only remaining is emotional intelligence. Now this is save standardized values and variables. So click here, save standardized values and variables. We do it and then we click on OK. So as soon as we click on OK, here we get the descriptive statistics, but this is not what we want. What appears in the database. So we go to the main database. Here you see we had this much of data, but now a new column has been introduced, and these are the Z scores. So these are the Z values, that is standardized values. Now here, if there is any value which is less than -3 or more than +3, so that you may consider as an outlier. So let us go down. Is there anything like that? Yeah, there is one person. You see this one whose serial number is this is FFE, and FFE is an outlier having much less emotional intelligence than all others. There is no outlier at the top. So this also we had seen, if you remember, in the previous video when we did the box plot, that we got the outlier as FFE. So that is how we identify an outlier over here with the help of standardized check values. Okay, let us move to the next agenda. Compute the frequency under different qualifications and draw a pie chart. Okay, so for doing this, we go to analyze, we go to descriptive statistics, we go to frequencies. So under that was the question was under different qualifications. Okay, so different qualifications. So we take educational qualification in this side, and then we go to charts, and then we go to pie chart, and then we go to continue, and then we click on OK. You may get a display of the frequency table. So if you check here, okay, that is a good practice, I believe. So here is the frequency table. So the frequencies are business graduates 14, engineering graduate 12, and general graduate 13, and accordingly we get this graph here for this. Now if you want to make some changes in the graph, then you may double click here. So the this graph editor window becomes visible here. So accordingly you can go here, click in this click in a particular pie and change the color, like make it this one. So apply. So you see color has changed. Click in the other pie, make it this color, apply. So this way you can make the necessary changes you want. If you get the data values, you want the data values and all, here and the option is there to get the data values. So accordingly you can get all these things, data values and levels. Okay, so this way you can get the educational qualification, frequency of educational qualification. Already you see the values are coming up close. So this is for one. You can get it for others also. Just you click outside, and so this you may try how these different things work out. Uh, some of them are not active, as you can see, because here there is no concept of x-axis and y-axis in a pie diagram. That's why some of them are inactive at this present stage. So we close these windows, and then we come back to next agenda, and then cross tabulate gender and designation. Also perform chi-square test of independence. So we have to cross tabulate gender and designation. So we come here, we go to analyze, we go to descriptive statistics, and we go to cross steps. So in cross steps, we have to cross step gender and designation. So we select gender and take it in this side. So gender gets selected. We click on designation, bring it in this side. So designation also gets selected. So this way you are taking the gender along the rows and the designation along the columns, and then you go to accept, and then sorry, you go to statistics, and then there is chi-square. So this is the chi-square statistic which tests the independence of attributes, that whether gender and designation has some relationship amongst themselves. So we click on chi-square, we click on continue, we come back here, and then we click on OK. As soon as we click on OK, we get the cross tabulated value. You see gender comes along the rows and designation comes along the columns. So gender versus designation. So this graph is complete. Sorry, this table is complete. You get the row total and the column total also for the purpose of comparison. And then we have the chi-square test. The result of the chi-square test is actually here in the first one, result of chi-square test. So this is the corresponding value of the chi-square, and this is the corresponding p-value. Now, since the p-value is more than 0.05, so we accept the null hypothesis. So what was the null hypothesis? Null hypothesis is that there is no relationship between gender and designation. There is no relationship between gender and designation, or gender and designation are independent of each other. That is the null hypothesis. Now, at this stage, we accept the null hypothesis. That is, we agree that based on this data set, the um, gender and designation, they are related to each other. So this is so accordingly, this is what we have done, that chi-square test tabulation simultaneously we have done. Let us go back to the next one. Row scatter diagram, age and salary after increment. Get the points differently colored by designation. Fit a straight line to the graph. Okay, so let us start with the scatter diagram. In x-axis it will be age, y-axis it will be salary of increment. So we go to analyze. No, sorry, we go to graphs. We go to legacy dialogues, and we go to scatter plot. So you take a simple scatter plot, we define it. So we along the y-axis we take salary after increment. So this one is salary after increment, we take it along y-axis. This is age, we take it along x-axis. And set markers by, we take it as here, designation of the respondent. And then we click OK. Once we click OK, then we see that this graph is being drawn, and officer, executive, and director, this designation, they are differently colored. So these colors, bubbles are not filled, these dots are not filled. And it is also sometimes you may find that the color is not suitable to be understand against a white background. So if you want to change this, just double click this. So it comes in the here, and then you select all this. So you select the directors, and then you go here. So you fill it up in green color. So it gets filled up in green color. Now this one, you click and this double click, so they get all covered with red. Then you go here, and then you color it with red. Okay, and then now blue one. So you click here, go to this. This one. So you see there is now this thing is getting colored. Now to get the fitted straight line within the scatter plot, what we do is that we double click it. We come to this, and here there is a option of the getting a straight line. So we just click there. So it gives me different options like linear, mean of y, lawless, quadratic, cubic, etc. Few options are there. Already by default linear has been selected. And we find that the straight line has been fitted, so we close it. So we come here and we get the equation also. Here is the equation. So this equation, we see the value y equal to 24.41 plus 0.55x. So that is x is age and y is salary after increment. So this is how we fit a straight line to the graph. If you don't want the position of this equation here, you can pull it to the side by just clicking and dragging it. So this way we can change the position of the graph. From So this way we go to the next agenda. Then next agenda is we have already done this next agenda. Find the correlation between age and salary before increment, between age and salary after increment. That means age, salary before increment, salary after increment. These are your variables. So what we do, we come here, we come here, and then we close this window. And we go back to the database. So this is our database. So each salary before increment. So we go to correlate and we go to bivariate. So bivariate correlate, and here you have to pull out the variables whose correlation you are interested. So you take age and then you take age, bring age in the right side. Then you get salary before increment and salary after increment and bring it in this side. So age, salary before, salary after increment. These all these variables we have in the right side of this panel, and then there are three types of correlation available: Kendall, Strauss, Spearman, and Pearson. So these two, number 2 and 3, these are non-parametric correlations. So we go with Pearson and then we click OK. There is an option, flag significant correlation. That means significant correlation will be star marked so that they can be identified. So when we click OK, we get a correlation matrix. So first one is the correlation between age and salary before increment. It is 0.676. So it implies that as age increases, salary before increment also increases. Here this is also significant, as you can see 2 star, and this is the correlation between age and salary after increment. This is 0.537. So and double star, that means that is also significant. These are the corresponding p values that you can see. It needs to be less than 0.05 for correlation to be significant, and so you can see here they are less than 0.05. And this is the correlation between salary before increment and salary after and age, and this is same as this one. So interpretation is also in the same way. Here you get this is the correlation between salary before increment and salary after increment. So you see there is a strong linear relation. The value is very high, positive, and double star, so it is significant. That means there is a strong relation between salary before increment and salary that is after increment. And so to great extent, the salary after increment is related to what salary was before the increment. So this is about correlations, and then we proceed to the next agenda, that is calculate the correlation between emotional intelligence and performance index. Okay, we come back here, we go to the data set, we go to analyze, we go to correlate, we go to bivariate. We bring this back because these correlations variables we are not desiring. What we want is that performance and emotional intelligence. So we select these two values, take it in the right side, and then in the same procedure we click on OK, and now we get the correlation between performance and emotional intelligence. You see it's 0.537, and this is also significant. That means the performance of a person is higher, then the emotional intelligence will also be high, and vice versa. Okay, moving to the next agenda, we have this fit a regression line, salary before increment as the independent variable and salary after increment as the dependent variable. Okay, we can do this very nicely. We come back here, so we go to analyze, we go to regression, and we go to the second option, linear. So once we click on linear regression model, then we have to select the dependent variable and the independent variables. So in the dependent variable, we put salary uh, after increment, that is our dependent variable, and salary before increment, that is our independent variable. So we bring it here, and that is all. We click on OK, and then we get the regression. We get the first one here, 3 tables we get. This is the ANOVA of regression. ANOVA of regression needs to be less than 0.05 so that the regression is significant. So ANOVA of regression is less than 0.05. We look at the value of R square, that is 0.735. So this is the value of R square, and then we have this particular table in which we get the regression equation. That means salary after increment is equal to 11.099 plus 0.882 into salary before increment. So this is the equation. Y equal to 11.099 plus 0.882 x, where x is salary before increment and y is salary after increment. We also look at the p-value of the regression coefficient, and we find that the p-value is 0.00. That means this p-value is small. This p-value this indicates that the um, uh, variable, that is salary before increment, is significant. So accordingly, we take this conclusion from fitting this regression equation. Okay, now let us look at this if age is normally distributed with probability plot, PP plot. Okay, so we have this and also test the normality of salary after increment using Kolmogorov-Smirnov test. So age is normally distributed, so we want to check it. So we go to analyze, and then we have in descriptive statistics. Here we have PP plot. PP plot is called as probability plot. So we want to check age and the distribution to be checked. Here we have some options, and here we see we have normal. Also by default it has been selected. So we have beta, gamma, other distributions also you can check out. So age normally distributed, and the parameters of the distribution will be estimated from the data itself, and then we click on OK. So we have this plot, and this is the 45-degree straight line, and if the data follows normal distribution, the points needs to be very close to the straight line. In fact, here it is to a great extent very close to the straight line. So accordingly, we can find out that this, or we can say that here the data is more or less normally distributed. But if you want to check it out through a statistical test, then the recommended statistical test is the Kolmogorov-Smirnov test, which you can find under the analyze non-parametric test legacy dialogues, and then there is one sample KS test. So look at the flow, analyze non-parametric legacy dialogues, one sample KS test. So we click on that and we take age from this side to this side for the purpose of testing. 4 options are there for testing, out of which we go with normal and we click on OK. So once we click on OK, we get the result of the test, and this is the p-value in order that the null hypothesis is rejected. Null hypothesis, the data comes from normal distribution. This value needs to be less than 0.05, but it is more than 0.05, indicating that null hypothesis is accepted. That is, the data comes from a normal distribution. So this is how we can check the normality of the data set. Thank you for watching the video. Other agendas will pick up in the next video.